Alright, this is lesson 42 for Algebra 1, identifying parts of quadratic graphs. So we're talking about quadratic graphs. They look like a U shape, right? So we talked about linear, now we're talking about quadratic, and we know how to graph them now. We're going to spend a little more time practicing that because that's a real hard topic, but the more you practice, the easier it gets. And then we'll do some application of that later. So today our goal is to look at a graph, and we're going to do these four things: identify solutions, we're going to identify the axis of symmetry, minimums or maximum, and identify the domain and range, okay? So here are the steps. If you're on the video, you should pause it. We're in class, so we're all ready to go. So just go through these steps. I have them written on the board here too, so here we go. Numbers 1 and 2. So on your homework, you'll have all of them already graphed. So step 1 is already done for you, okay? Just because I wanted to alleviate that step so you don't get distracted, okay? So all the problems are already graphed. So let's pretend you had to graph it. You graphed it already. That's step 1. The next thing you're going to do is we're going to look at our directions and just answer everything that it's asking for. So it's saying identify any solutions, okay? So the first thing I want to do when I want to identify solutions, I want to look at the graph and identify where does this graph touch or cross the x-axis, okay? Where does it touch or cross the x-axis? So it crosses the x-axis here, and it touches right at the bottom here. So at what point does it touch? I look closely. It's touching right here. What's x equal to here? What's this point? Well, x is equal to 0, right? This is the only point it's touching. So our solution, I write down solution. There's only one solution, and it is equal to 0, or x is equal to 0. Okay, that's the only solution. Sometimes there's two, sometimes there's none, okay? Continuing, the next thing it's asking for is a minimum or maximum, okay? So you have to think about minimum or maximum. Is there a point at this point, is there a maximum point this graph gets to? No, it doesn't. It keeps going up forever. There is no maximum. There's no, like, ceiling of it. It keeps going up forever, theoretically, because we have two arrows at the end of this graph. So we know it goes up forever. However, there is a minimum, and it goes down to this point right here. So at what point is it a minimum, okay? So we want to figure that out. Oh, I skipped symmetry, but we'll come back to that. So the way we figure that out is you look at the vertex. So I'll leave a little space for axis of symmetry. Min or max, okay. So look at the vertex right here. What's the vertex at? It's at 0, 0. Okay, so if you look at the step here, it says the minimum or maximum, you just put y is equal to, and then we take the y value from our vertex. So we would say this is a minimum, and the minimum is that y is equal to 0. We're just copying this number down here. That's all you're doing is copying that number to here. Okay. Then going back, I forgot to do axis of symmetry. So the axis of symmetry is what point is it reflecting across? It's this line in the middle, and the axis of symmetry, I'm just going to write AOS. You write x is equal to, and you copy the number from the x part of your vertex over here. So our axis of symmetry is this line in the center. So, and if we were to draw it, the axis of symmetry is this line down the center. So I would take my straight edge and just draw a line. This is my AOS. Okay, and then we have a minimum, which is this line that crosses right here. This is our minimum, so I'm going to write minimum. Okay, and the last thing it's asking for, or the next thing is domain, okay? So I'm going to write down domain, and we already know what domain is, so we're asking ourselves, how far to the left does this graph start? Well, it keeps going up into the upper left direction, which means it always goes left, so it starts at negative infinity. And it goes to the right, and there's an arrow here at the right. It goes to positive infinity, and it never really touches infinity, so we use parentheses. And by the way, this answer is always the same for quadratics, the domain, okay? Excuse me, I need to get a drink of water. Okay, last thing is intervals of increase and decrease. it increases. So we'd write increase. It increases from this point right here, x is equal to 0, and it keeps going up forever, so we would say 0 to infinity, it's increasing. And it's decreasing from from negative infinity, excuse me, all the way to 0. So that's how we do number 1. Okay, so number 2 now is the same thing. You start with figuring out, identify any solutions. We're asking ourselves, where does this graph touch the x-axis? Now, is this graph touching the x-axis at all? No. So if it's not touching, there are no solutions. So we'd say no solutions. That's the first thing. And to be specific, no real solutions, but you don't need to know that right now. Okay, the next thing is asking axis of symmetry, so that's where the vertex is. We're trying to find the vertex first, so our vertex here is at negative 3 1/2, and it goes down to negative 3. Okay, so axis of symmetry is this line down the middle, so I would take a straight edge. And just draw an axis of symmetry like so. This is our AOS, and we're going to identify our AOS underneath here. AOS, or axis of symmetry, is at x is equal to, and we take the x value of negative 3 1/2. Place it down there, okay? Make sure your phones are off, okay? I don't know whose that was. Make sure you turn it off right now. Okay, next one is minimum or maximum. I have to ask myself, is there a minimum or maximum point on this graph? What do you guys think on number 2? Minimum or maximum? There's a maximum, right? It doesn't get any higher than this point. So our maximum here, we write maximum. And what is our maximum? Well, we're going to write y is equal to, and then we take the point from the vertex, copy this right down here, negative 3. Okay. Next thing it's asking for is domain. Domain is always the same for this type of graph. It starts at negative infinity and goes to positive infinity. And increase or decrease. Okay, so we have levels of increase from, or an interval of increase from negative infinity. You see how it starts from way down here and it keeps increasing up to here. So this is our increase from negative infinity all the way to 0, putting brackets around that. And it's decreasing from 0 to positive infinity. So that's it, okay? So a lot of this will be repetitive. So it's either going to be one or the other. Domain is always the same for any type of quadratic graph. Drawing your axis of symmetry and so forth. So that's what we're doing. We're identifying. Are there any questions here? Are you all understanding each topic? We all know domain and range, or domain and increase and decrease. Yes.
I have a question about
So minimum is how. When you ask minimum or maximum, is there a point that it gets to the highest? Is there a maximum point, or is there a point that it gets to the lowest? Right. So that's the lowest, the minimum, right? So you have to think kind of conceptually. Which one is? Does it ever get to the highest point or to the lowest point? Or does it get to the maximum point or the minimum point? That you have to figure out. So maximum means that the graph opens down. Minimum means the graph opens up. All right, good question. Any other questions? Okay, so are we graphing today?
No.
No, we're not graphing today. That's not the goal of today's lesson. So tonight's homework, there's no graphing. Yay. But there will be homework where you have to do both, graphing and then telling me all this information, okay? But not today. All right, so I want to finish up, talk to the ones about number 2 now. Ready, set, talk. Okay, so again, you're not graphing these. Let's look at number 3 together. Shh. I need you to end your conversations. Thank you. All right, so I'm going to just hide number 4. We'll come back to that in a moment. Okay, first thing on number 3. It's already graphed for us. If it wasn't, you would have to graph it. Okay? Okay, identify solutions. Does this graph cross the x-axis? Yes or no? Does this graph cross the x-axis?
Yes.
Yeah. How many times does it cross?
Twice.
Twice, okay? So it crosses here and here. Now, if I were to look closely, it doesn't cross perfectly. So I'm going to, on my paper for now, there is a way to do this perfectly, but it's not what you need right now to know. Right now, we will look at this more detailed in a few weeks. But the solutions cross at about -2 and at about 0. So then I would write x is equal to, but watch what I do with the equal sign. It's not perfectly equal to. I'm going to put about, or use the equal sign that has like a squiggly feel to it. It's about 0 and it's about -2, right? It's not exactly those two, but it's about there, okay? Y'all doing this, right? Okay, what's the next piece of information I'm trying to find? Axis of symmetry. So to find that, what do I have to identify before I even get that? The what? The vertex, right? Where's our vertex at, everyone? Nope. Here's the origin, so we'd have to go, what's this? What's the vertex at?
0.
No.
-1,
-1, 2. Okay, so our vertex is at -1, 2. Okay. So axis of symmetry on your, on your homework, you would have to graph a line like this, like draw a line for me, like this. Oh, I'll draw that again. Okay. And we'd label it AOS, or axis of symmetry. Okay. What's the equation for axis of symmetry? What letter do I start with? X. X is equal to what? Look at your vertex. What's the x value in your vertex? -1. So we're copying, literally you're just copying -1, and you're putting it as your answer right here. Okay? Continuing. What's the next piece of information it's asking for?
minimum and max.
Minimum and max. Does this have a minimum or a maximum? Does it have a highest point or a lowest point? So it has a minimum or maximum? Good. So it has a maximum, so we're going to write maximum. And of course, on your graph, you would also draw a dotted line at crossing the maximum, like so. So that wasn't perfect. Here we go. That's better. Okay. And we would write maximum. Okay. Okay, what's the equation for the maximum? What letter do we start with for maximum? Y is equal to what? To 2, right? Good. Y'all following me so far? Okay, pretty easy so far. Next is what piece of information is asking for? Domain, okay. Domain is always the same. What's domain? Negative infinity to positive infinity. Good. This answer is always the same for quadratic graphs, okay? In Algebra 2, we'll do parabolas. That's different. Looks similar, but it'll be more advanced when you get there. But for now, its domain is negative infinity to positive infinity. Okay? And last thing, what's the last piece of information it's asking for? Okay, good. So intervals of increase and decrease. So just like last week, we know that the graph increases from where? Where does it start increasing from? Mm-hmm. Good. To? No. When does it go to increase? It's not to 0. What x value does it keep going increasing? When does it? What is the value of x here? Nope. -1. What's the value of x here? What's the value of x here? -1. No, not y, x. What's the value of x? Did you all forget how to do increase and decrease? It goes to only to -1, okay? Right? When does it go decreasing now? When does it start to decrease? Start with the same number. -1 all the way to positive infinity, right? Does that make sense, everyone? Okay, so all we're doing is we're identifying today, okay? You're not graphing today, but when you graph on one of your homework problems or even a test problem, you might have to graph the whole thing and give me all this information, and this might be like a huge multi-point problem. Okay? Let me see your answers. Your answers should all look like mine, because if they're not, you're not following directions. So you lost the iPad if you're not on there. Okay? You could do this on a sheet of paper. If you guys aren't on task, then you lose your iPad, okay? Last one, number 4. Okay, I'm going to cover number 3 now. Oops, sorry, number 3. Okay, so looking at number 4, first piece of information. What are we asking for? The solutions, okay. What solution do we have? Everyone looking at the board. How many times does it cross the x-axis? Once. Okay, tell your neighbor what the solution is. But what is it also? X is equal to what? What's x equal to, everyone? No, at 0. X equals to 0. Remember, you're asking yourself, when does this graph cross the x-axis? X is equal to what here? 0. Good, okay. Even though there's one solution, it's still x is equal to 0. Okay. Recording here. All right, what is the axis of symmetry? So let's figure out the vertex first. What's our vertex, everyone? 0, 0. Right? Would you all agree it's 0, 0?
Yeah.
Okay, good. So on your homework, you would draw an axis of symmetry right down the center of the graph. Sure, let me see if I could get this to look correct. Okay, and then we would write AOS. Now, what's the equation for the AOS? X is equal to? X is equal to what on this one? 0, right? Same thing. All I'm doing here is you're just copying the vertex, the X part right there, right? That's all I'm doing. You all see that? Okay, so this isn't a question of like difficulty. You're just identifying parts right now. It's very low depth of knowledge. Okay, next one is minimum or max. Is there a highest point or lowest point on this graph? Is it a minimum or maximum then? Minimum or maximum, everyone? Maximum, good, okay. Okay, so since it's maximum, we're going to draw our line crossing that same vertex, running perpendicular. So y is equal to, what's y equal to here? 0, right? Because all I'm doing again is I'm just taking the y value from our vertex this time, copying here. X and y are 0 on this one, so. But each problem will be different, okay? Continuing on, what's the next thing it's asking for? Domain, right? Okay, what's the domain always for our quadratic graphs? Good, negative infinity to positive infinity. They're just always the same, okay? We know that not all graphs are the same, but for quadratic graphs, it's negative infinity to positive infinity. Okay, level intervals of increase and decrease. When does this graph start increasing? From negative infinity. And when does it stop increasing? 0. Excellent. When does it start decreasing? What's that? 0 to positive infinity? Is that what I heard? Okay, good. Excellent. All right. Are we done?
Yeah.
Okay, let me see your graphs, or your answers, okay? And then this concludes the lesson.